Kia ora. Hi, it's me, your teacher. This video is to go through slightly more complicated branched alkanes. So in this video, we're going to be looking at alkanes that have multiple branch chains. So the ones we looked at previously had only one chain of varying size. In this case, we're going to be looking at molecules that have two or more branch chains and how you can name them. Because remember, the important thing is that we want to be able to name this in a way that somebody else could draw it. So we have to make sure that all of the information is present in our kind of organic chemistry language code thing. So we have got here a five carbon chain that has got two single carbon side chains attached. So that's kind of important information to have. We need to make sure that our organic name gives us all of this information. There's 5 carbons in the main chain. They're all single bonded together, and there are 2 side chains, and both of them are methyl groups. They're both single carbon side chains. So just a reminder of how we do this. So same naming technique as we have for the previous videos. It's exactly the same. So number 1, meth. Number 2, my brain just stopped worked. Oh no. Having a moment. Eth. 3 is prop. 4 carbons is bute. And then we're on to our shape naming. Pent, hex, hept, and oct. And then because it is a side chain, our suffix is -iles. This tells us that it is a side chain and not a completely separate molecule. And remembering, of course, that our single carbon-carbon bonds is a functional group, is an alkane functional group, which means that our suffix for our whole molecule is going to be -ane, just like the previous ones, but we're sticking with our side chains for now. So naming a side chain, same numbering method as previously, with -ile as our suffix, so methyl, ethyl, propyl, butyl, etc. Our next step, so we've worked out how to say what type of side chain we have. Our next step is to tell our reader that there are 2 side chains. So 2 side chains and that they're the same. So we have a way of numbering or counting side chains, so saying how many we have, which is different to counting numbers of carbons, because we're now counting groups of things. I don't know why I wrote 1 in there, because you just don't say anything if there's 1. If there are 2, so let's take our methyl groups as an example. If we had 2 methyl groups, we would say, I'm dumb, none of that, dimethyl. So di is our prefix for 2 groups of that thing. If there are 3 methyl groups, it'd be tri. And if there were 4, which with this you can't have, but you can with haloalkanes, it'd be tetra. So dimethyl, there are 2 methyl groups present on the molecule. 3 trimethyl, there are 3 methyl groups present on the molecule. And 4 tetramethyl, there are 4 methyl groups present on the molecule. So in this case, I have got 1, 2 side chains, 2 methyl side chains. So that would mean that this would have to have dimethyl somewhere in the molecule. So that tells me I've got 2 times CH3 groups in my molecule somewhere. So remembering again that when we're numbering our side chain, carbon number 1 is the closest to the interesting thing. In this case, we have got 2 interesting things, and they are the same, which is a problem. But what we can do in this case is actually not too bad, because they're both on what would technically be carbon number 2, so either carbon could be number 1. But basically, because they're right next to the carbons, you can choose, but otherwise it is still the carbon that's closest to the closest interesting thing. So for example, if this CH3 group is actually here, then this would be the only one that could be carbon number 1, because this carbon would be too far away. So just sort of pay attention to where everything is. so that you can number them. But in this case, either carbon can be carbon number 1, so I'm going to give this side the number 1 in this case. So it's just a matter of paying attention to what is present on your molecule, how close they are to the ends, and if one side is closer to something than the other, then that's the side you go with. So in this case, finally, we can now name this molecule before we move on to a slightly different one. So here we, again, always start with your longest chain. So in this case, my longest chain is 5 carbons. So that means that it is pentane is kind of my main body of my molecule. And then I'm going to talk about my side chains. So I've got methyl groups. I have got 2 of them, so I'm going to put dimethyl at the front there. So this, so far I've got 5 carbons in my longest chain, and all of those carbons are single bonded. That I have got 2 times CH3 groups, but I still haven't told my reader where those methyl groups are. So I'm going to do that now in a very similar way to when you've only got 1. So they are on carbons number 2 and 4. So I'm just going to separate those by a comma. So 2, 4 dash dimethyl pentane. This tells me that on carbons 2 and 4 are where my 2 CH3 groups are placed. I've got 5 carbons in my longest chain, and they're all single bonded together. So 2, 4 dash dimethyl pentane is the name of this molecule, and it gives us all of the information that we need to be able to draw this molecule. So that's kind of the easy version, because both of these are the same type of side chain, so we can group them together like this. When you've got 2 different types of side chains, that's when it gets slightly trickier, but also not really. Maybe it's easier, I don't know. Well, you decide. So when we have different side chains, so in this case here, oh, I think I've mucked this up, hold on. Okay, pretend it always looked like that. Okay, so when we have different side chains, so here you can see that we have got a single carbon side chain and a 2 carbon side chain. The reason I had to just fix this is that my longest chain would actually have been this L shape, because it would have been 1, 2, 3, 4, 5, 6, 7 carbons against a 1, 2, 3, 4, 5, 6, 5, 6. So it would have just been 2 methyl groups, which is not what I wanted. So I've added another carbon on the end now, and now the longest chain can either be the L shape or the straight chain. So it's fine. Ignore me. Shh, everything's okay. Anyway, we've got 2 different side chains here, so we can't group them together with the di-tri-tetra method because they're not the same. We've got a methyl and an ethyl. They're different words. They cannot be collapsed in together. So same method as before. I am going to count my longest chain, which is 7 carbons now. So hept for 7 and ane for single carbon-carbon bonds. I have got both a methyl and an ethyl group that I need to place in my name. And I also need to tell my reader where on the chain they are. So let's start with where on the chain they are. I need to give priority to a carbon. So this carbon on this end is 1, 2, 3, 4 carbons away from something interesting, the methyl group. And this carbon here is 1, 2, 3 carbons away from something interesting. So we're going to name this carbon here number 1 because it's closest to an interesting thing, and ethyl is actually... Hi, it's me, your teacher, but like from the future, because I realized that I said dumb things. So I'm just going to fix that really quickly now. You may notice on your worksheet that it tells you to number your side chains in a way that produces the lowest possible sum. So what I mean by that is that instead of assigning ethane a higher priority, because that doesn't always work, so we're not going to assign ethane a higher priority. We're not going to say that ethane is more important than a methyl group, therefore the carbon that's closest to that one needs to be carbon number 1. Instead, we're going to look at the numbers of the carbons that we are using. So what I mean by sum is that I mean the assigned carbons added together. So in this case, we've got 3 ethyl, 4 methyl, so 3 plus 4 equals 7. So we want to make sure that our sum is the lowest possible number. Basically, we want to make it as simple as possible. So the lowest possible number for this is going to be 7, because if I had decided that my number 1 was going to be, let me just draw this out again, hold on. That my number 1 carbon was going to be the one on the left, that would mean that my total would be 4 plus 5 equals 9. And that is bigger than 7, which means that this one is going to be the priority, or this one is going to be the preferred naming convention for this particular molecule. So carbon number 1, oh no, go away, 2, 3, 4, 5, 6, 7. So I need to separately tell my reader where the ethyl group is and where the methyl group is. And I'm going to do this in alphabetical order. So that's important for your naming. It's alphabetical when you're working with things that are different. If they are the same, then you collapse them with your di-tri-tetra. So here I am going to start with my ethyl group because E comes before M. So my ethyl group is on carbon number 3, 3 ethyl, and my methyl group is on carbon number 4, so 4 methyl. So here, if I check myself, I've got 7 carbons in my longest chain and all of them are single bonded, yes. On the 3rd carbon, there is a 2 carbon chain, which there is. And on my 4th carbon, there should be a single carbon chain. Yes, there is. So again, this gives us all the information that we need to be able to name this molecule. It tells me how long my longest chain is, where the side chains are, and what the side chains are. So here, I have some practice again for you. I've got 2 molecules for you to name and 1 molecule for you to draw. So to give you a hint, this one here is 3 ethyl, 4 methyl heptane. And here, I want you to draw me 3 ethyl, 2 methyl heptane. I'm just going to use my brain real quick. Yes, that should work. That is, I think, correct. So A and C, I want you to name, and B, I'd like you to draw. Pause the video, come back, and then we'll see how we did. Clap, clap, clap. Pause, pause, pause. Okay, you're back. Awesome. So here, again, number 1, we are going to name our longest chain, which in this case is going to be the straight chain here. We've got 4 carbons. 4 carbons means butane. They're all single bonded. We then want to look at what our side chains are. We have got 2 times CH3, which means that we have a dimethyl here. And then I want to tell my reader where they are. Doesn't matter which carbon I pick to be number 1, so I'm going to pick left. So that means that on carbons 2 and 3, I have a methyl group. I'll do C first and then I'll go to the drawing. So C here, I have got 5 carbons in my longest chain, so pentane, and on carbons, again, it doesn't matter which one gets priority, so I'm making it easy on myself. On carbons 2, 3, and 4, I have got a methyl group, and because I've got 3 methyl groups, I can collapse them with my di-tri-tetra, so this will be trimethyl. So 2, 3, 4, trimethyl pentane. Just one thing I will mention because I forgot to say it in the rest of the video. If I had a CH3 group here, and pretend that these aren't there, I would name this 2,2 dimethyl pentane. So when you've got a CH3 group on the same carbon, which can happen, you still have to name them both with their own number. So everything gets its own number, even if it's the same as something else. And then finally up here, we have got, so heptane. So when I'm drawing, I follow the same method. I'm going to do draw my longest chain, so 7 carbons. I'm just going to get my end carbons, they're hydrogens. On the third carbon, so I'm going to just number them left to right again to make my life easier. So on the third carbon, I've got a ethyl group, so 2 carbon side chain, 1, 2, 3, 4, 5, 6, 7, okay, it's fine. A 2 carbon side chain, so 3 ethyl and 2 methyl. So I've got a single carbon side chain on carbon number 2 and a double carbon side chain on carbon number 3, as it says. And let's just pretend the rest of these lines are hydrogens, sorry. So again, 7 carbons in my longest chain, yes. For the hept, they're all single bonded, yes. For the ane, on my second carbon, carbon number 2, I have got a single carbon side chain, yes. And on carbon number 3, I've got a 2 carbon side chain, yes. Cool. All right, hopefully that was helpful. Like and subscribe. Kia ora.